So, good morning, everybody. It's nice to be back at the Codejam after several years of not being able to attend. So today I'm going to present to you what's new in NEST, and I think NEST itself needs no great introduction. It is your tool of choice for large-scale simulation of point neurons or pointish neurons, and is part of the EBRAINS effort. Before I go into the details of the new things with the recent releases and what we can expect with the next releases, maybe just a word or two about our long-term goals. So obviously we have a long-term goal of continuous improvement. For example, our focus at the moment is on the model directory and on improving our PyNest examples. We're also interested in the moment at enhancing the visual elements, elements of NEST. And of course, a major topic at the moment is integrating NEST with EBRAINS, including the integrated documentation. So in this talk, I'd like to first of all tell you about changes that have recently occurred with NEST. Excuse me. Sorry, I seem to have inhaled some dust in my excitement. Tell you a little bit about some recent changes to NEST, and also some changes in the peripheral software around NEST, being NESTML and Nest Desktop. But for the majority of the talk, I'd like to talk about what's going to be new in NEST, and namely NEST 3.0, which is going to be a big change on many levels. And I would like to finish up with a few words about documentation and community. So, we have had 2 releases since last summer, NEST 2.18 and 2.20, and these have been fairly minor releases in terms of they didn't break anybody's simulation scripts. What we have done is included new neuron and plasticity models, and a lot of stuff behind the scenes, so improving memory allocation and performance, enabling some more convenient installation options, and a lot of improvement of documentation. So here is a list of the new models that we've introduced. Perhaps the thing that we're most pleased about is some of these synapse models, including the Clopat STDP synapse and the Abanchik Sen synapse. These are more conceptually more demanding than the regular kind of STDP, so there was quite a lot of work involved with that. Moving on to NESTML, so this one I do give a brief introduction to because perhaps not everybody knows it. NESTML is a domain-specific modeling language, and this stems from the fact that previously, in order to make a new model in NEST, you had to be able to write the C++ for it, which is something that not all neuroscientists can manage equally well. And even for people with training in C++, there was an awful lot of boilerplate code, and there was possible to get errors involved by overly keen copy pasting. So we developed the NESTML modeling language that enables you to express a model in a very succinct fashion, which is close to the concepts that a neuroscientist have. So on the right-hand side, you can see the code for a neuron model with exponential postsynaptic currents. And if you ever looked at the corresponding model in NEST code, it's 2 files and several pages of code, several hundred lines of code. And this is obviously a whole lot easier. for the user, for the developer of models. The main things that we have that are new in this are improved specifications of differential equations and convolution kernels, and we've spun off this functionality to a separate Python toolbox, which is linked here. And this means that you can also use this for languages or for simulators that are not Nest. Anyone can use the same toolbox to generate appropriate ODE solvers for their simulator. But part of the reason why we've spun this off and why we've been working so hard on the equations and the convolution kernels is in preparation for the NESTML Synapse, which is our current major goal. And over on the right-hand side, again, you can see an example of an STDP synapse written in NESTML, which again, compared to the C++ code, is very compact and very easy to understand. And so we hope that this will enable users to really experiment with lots of different plasticity rules. Nest Desktop, again, I give a couple of words of introduction for those who don't know it. Nest Desktop is a very easy user interface for Nest. It's browser-based, it's graphical-based, so you can basically drag and drop your network components, alter the parameters, run a simulation, alter something again, run it again with no program experience. You can do this with high school kids if you want, and it gives a very intuitive way for new users to play around with networks and to discover some basic things about neural dynamics. And so it's really good for e-learning, which is, of course, particularly an issue at the moment, and can be also used in a classroom setting when we can go back into the classrooms. So the new things that we have with this is that the Nest server has been implemented in Nest 3.0, which I'll tell you some more about later. We can now design networks in Nest Desktop that have got some topology to them, and it's got increased functionality with the kind of charts and so on that it can easily display. And what we're hoping to achieve with this in the coming few releases is to have a live simulation visualization via the in situ pipeline, and to be able to use NESTML interactively with the Nest Desktop. So you can design a neuron model and then straight away simulate it without ever compiling Nest or ever having to write a line of C++. And this, I'm very excited about the possibilities that this have for students and new users, and I think the developers involved with this, largely Sebastian Spreitzer on the Nest Desktop side, but also the NESTML team and the in situ pipeline team, they're doing some really great stuff here. So now moving on to the bit that I want to spend most time on. What we're expecting soon is Nest 3.0. This is, of course, we've gone up a number from 2.0 to 3.0, so we expect great things from it, but also should be clear to everyone that this will break every single simulation script that you have. You're welcome. So, but we never do these things for no reason. We have good reasons for all of these things, and the time that you take to adapt your scripts, you will get this back many-fold in better simulation times and just generally more satisfaction with your code. So some of the major features of this are the node collections and synapse collections for managing sets of nodes and sets of synapses. And this makes the whole interaction with nodes and synapses just so much easier, so much less typing, and it's much closer to the what you're used to be able to do with Python arrays and so on. That these are iterable collections, and you can and especially in connection with the new approach to parameterization, it makes specifying your networks just so much easier, so much more pleasant. Also, we've integrated the topology function, so those of us who have done any network modeling with Nest, you know, if you want to make a spatially organized network, then you need the topology module, and this has now been merged with the rest of Nest, so you don't need to call in a separate library. It's all like in the box. And we've also made some major changes to the recording, which have also become just more compact and easier to handle. So I'll show you some examples. The thing you'll notice most about Nest 3 is that the code is more expressive and more compact. So on the left-hand side, you can see a kind of a typical setup for some network that that you're arranging. You're creating some neurons and setting the membrane potentials in a random way. And now you can do this in this very brief snippet of code on the right-hand side. And the some of the less obvious thing, so you can see, of course, that the code has got shorter, but actually it also has increased the performance of the simulator. So the connectivity connection has got much smaller, and also the simulation time is shorter due to some of the behind the scenes changes that are strongly entangled with this more expressive code. So let's talk about node collection and synapse collection. So on the left-hand side, you can see how we would do it in Nest 2.x, that you can create a list of 10 GIDs, global identifiers, and then you can use those as arguments in Connect. And then on the right-hand side, you can see how it looks in Nest 3.0. And as you can see, there is nothing to see. So it looks identical, but the difference is that now the NRNS is a node collection object, and we can do things with that you couldn't do with a list of GIDs. It has an efficient internal representation, and it allows you to slice and compose and then have a new node collection returned. And so as a rule of thumb, everywhere previously you would have used a list of nodes, now you use a node collection. So here are some of the nice things that you can do with node collection. You can print it, and it will give you a sort of an abstract representation of what's in there. You can print the like specific indices of it. You can adapt it inline. So in this third example, you within the print statement, you are adding another 3 neurons to it. And with these node collections, it makes it much easier, much more convenient to get and set node attributes. So on the left-hand side, you can see what we would have to do in order to set the some attributes of the node. So first of all, we create some neurons with an alpha-shaped postsynaptic current, and then I need to set the status. So I have this set status command, and it gets nodes as an argument, and then a dictionary containing name of the attribute I want to change and the new value. And then if you compare it with the right-hand side, I can just straight away on the node collection call out that attribute and set it without any dictionaries, without passing nodes in as an argument. It's just much cleaner, much more tidy. Again, at the bottom is another example for if I wanted to set 2 parameters, then I need to send in a dictionary that contains the key and the value. And now I can do that in a much tidier way, just directly on the nodes object itself. Much the same holds for synapse collections. This gives you an efficient internal representation for collections of synapses that you can then set the parameters of in a very tidy and convenient way. I mentioned the topology before, so we've now unified the topology connections with the connection connections, the connection commands that we had before. So now you can do things like define a grid with the command grid from the spatial module, and then you can create a whole bunch of neurons that have positions given by the positions determined in this grid. But you don't have to just create it as a grid. You can also create positions freely in space based on distributions or based on some explicit positions. So this gives you a much easier, finer control over the spatial organization of your networks. So these things, many of these things would have been possible before with the previous versions of NEST, but they required some quite advanced knowledge of how to deal with the topology library, and now these functions are much more accessible, much more comprehensible. So here again, the comparison between the NEST 2 series and the NEST 3 series. On the left-hand side, we can create a spatial grid which has got 15 rows and 10 columns by sending in a dictionary. And now we can create, first of all, the positions with the spatial grid, and then we can simply create a node collection which assigns those neurons to those positions. And then once again, they can be connected using any of the many connection rules that NEST has available. I mentioned before that the node collections and synapses were particularly useful in combination with our new approach to parameterization in NEST. So I'd like to talk about that for a little bit. So we can have parameters that are drawn from a random distribution and based on spatial node parameters. For example, we think of distant dependent connectivity and so on. And the things that we want to do with parameters is do things like set attributes of nodes, create their position, define the connectivity, probabilities and weights and delays. So we have increased the functionality of parameterization in NEST to make these things easier. So we can now, for example, set the membrane potentials from, for example, here, a normal distribution, whereas previously you would have to create the list of membrane potentials externally and then pass it as a big dictionary to the set status command. Now you can just set it from a distribution in one line of code. The same is true for spatial parameters. We now have built in a lot of random distributions that will allow you to do things like set your connection probability or your wait or your delay, depending on some model that you have for how these should vary over distance. And here we have an example where we're setting up the connection probability based on a what is it, beta distribution. Can't see, I've got the exponential distribution. I had all your faces over the code. And so we can see here what that would look like for a particular node. We can see the number of connections it has with the other nodes around it. Also, a whole lot of inbuilt mathematical and logical parameters, so that makes it easy to do to use these expressions in combination with each other to design a particular pattern for your connection weights. For example, here we have that the connection weights should either be rather small or rather large, but only 5 for that. We only have a few number of connections for a particular band of connection weights. So I think it's obvious to anyone who's done any large-scale network modeling with NEST that this frees the user to have, again, a much more fine-grained control, much easier control over the precise specification of their networks. Now, moving on to recording backends, we've got a new infrastructure for handling recordings, and we've built in backends for recording to memory, to ASCII files and screen. This is seems similar, at least, to what you're used to from NEST 2. From the NEST 2 series, but using them is now, again, much simpler, much less code, much fewer arguments, and additional backends for special applications can be enabled if you need it. So, for example, efficient binary files for HPC machines, or if you want to couple it to a different simulator. And you can make your own recording backend, but no NESTML for this. You will have to do it in C++. So here's, again, the comparison between the NEST 2 and NEST 3, what you'd have to do to send your recordings to different places. Again, you'd need to use the set status command with the name of your recorder as an argument, and then a dictionary telling it where to record to. Should it record to a file? Should it send it to the screen? Should it send it to memory? And now you don't need set status. It's a function of the recorders themselves, and it just really reduces the amount of clutter in your code and makes it much more obvious also to new users what's going on here, what all these commands do. So I'm convinced that these changes in NEST 3 are going to improve the usability of NEST considerably, both for the advanced users who want to have that fine and specific control to implement very specific connectivity models in their networks, and also for new users who want to understand quickly, how can I set up a network, how can I record from a network, how can I connect my neurons. If you like to have a look at how to convert your networks from NEST 2.x to 3.0, we have a comprehensive conversion guide. Go ahead and check out our documentation on Read the Docs. And that brings me neatly to the concept of documentation. So we have made major changes to the documentation in the last couple of years. We've completely redesigned the approach based on our understanding of the fundamental concepts, that the documentation should be easy to find and use and understand, but it should also be easy to write and maintain. So there's been a lot of work going on behind the scenes, and really this deserves an entire presentation all by itself, which I'm not going to do. However, if you'd like to know more about NEST documentation, then of course there's the eBRAINS Winter of Documentation project, which has the kickoff during this event here. But also we have a pre-recorded talk on YouTube, which you're welcome to go and check out, and it will explain everything that's going on with the NEST documentation, the motivations behind it, and the implementation of it. This then finally brings me on to the NEST community. If you are a NEST user or NEST developer, then there's the mailing list, which should come as no surprise. There's the video conference, where we have every 2 weeks an open video conference where anyone can join and discuss development and features. And we also have our yearly conference. This year we had it entirely virtual, and we had a huge number of attendants. Next year we are still open to how we're going to do this. It could be virtual again purely, or we might try to have some hybrid conference, because whereas we missed the in-person conference, we were also very impressed by the opportunities offered by a virtual one, that we could reach a far greater number of people than with the in-person one. And of course we have the regular hackathons. So if you want to get involved with NEST development, then please come and take part in a hackathon, and we will empower you with the knowledge and the excitement to get involved. So that brings me to the end for today, and thank you very much for your attention.